All right, Amy, we're ready for you.
Oh, great. Good. Thank you so much for everybody who stayed in the room. I hope that this doesn't disappoint. I'm very sad to not be there. I'll just say that ahead of time, not just for technical issues, but also because I've been looking forward to this conference for 2 years. So I'm sad, so now I have to look forward to the next one. But I'm Amy Villamagna. I'm coming from Plymouth State University, and I'm super excited to talk to you about this project that we've had going on for several years with my collaborators, both at the University of New Hampshire as well as at our New Hampshire Department of Transportation. All right. And of course, now I have technical issues not being able to advance my slides. Always figures. Here we go. Okay. So, based on all the talks, based on the reason why you're in the room, you know that wildlife vehicle collisions are bad. And I'm not going to spend much time talking about it except to distill it down to it. We have a biodiversity crisis. Roads are the great fragmenter, and you already heard multiple times today of all the wonderful things that roads do for our planet. But it's also an issue of human safety and well-being, which was largely the motivation of at least the projects that I'm funded under. So I just want to introduce you to a lot of our land mammals. We also have some larger birds that are problematic in terms of our wildlife collisions here. So just to introduce you to a little bit of New Hampshire wildlife here, you can look at this wonderful poster and see we have some large species, probably not as large as out west, but we do have our black bear, we have white-tailed deer. You hear that being talked about repeatedly. We have very large moose. And then we also have some red fox and bobcats that are some of our priority species in crossing roads, as well as turkeys. So New Hampshire is quite a ways away from you all right now, but I wanted to give you a little bit of insight into what our state looks like because it all pretty much informs our issue with wildlife vehicle collisions. And in this case, we are not explicitly talking about roadkill. We're actually talking about just the collisions themselves. So don't assume I'm talking about roadkill when I say WVCs in this talk, like the last talk. So our state is about 83% forested, which means we still have a lot of viable habitat left to support wildlife throughout our region. We also are a growing population, so we are pretty low density in terms of development, but over the past 30, 50 years, we've been growing fairly rapidly. And so we've doubled in size in terms of population since 1970, and that means more roads, more houses, more fragmentation, less habitat for wildlife as we proceed. In the map in the middle, you can see the White Mountain National Forest is in the central to northern part of our state, and it does make up a large component of our area. And so that's a great refuge for a lot of species, which can also lead into having collisions near those areas. We have less than 17,000 miles of public roads, and only about 27% of those are managed by our State Department of Transportation. And I shared with you over here on the right-hand side a little bit of information about our road condition, mostly related to paving, to give you just the idea that we have the opportunity in areas that roadways are not in good or fair condition to be making some changes for the better when it comes to safe passage for wildlife. So our project is a multi-year project. It started several years ago, back at least my involvement in probably 2020. But it can be broken down into these 5 phases, including the very first one, which was problem recognition. And this occurred before I was on the scene. This happened within the New Hampshire Transportation and Wildlife Working Group, which is comprised of people from our various state agencies, our Fish and Game Department, as well as Department of Transportation, as well as the Nature Conservancy, federal agencies, and several other non-governmental organizations. So that problem recognition happened, and it really fueled 2 parallel pathways. One occurred within New Hampshire Fish and Game, and that focused on wildlife corridors to try to predict where wildlife were using land to be able to connect between large, otherwise intact habitat. And also New Hampshire Department of Transportation's push to better understand the data that is accessible and what could be done with wildlife vehicle collision information. From that, we moved into a phase where we were prioritizing roadways. At first, that was for mitigation, but I'll explain to you why it ended up having this intermediate step related to field validation or a field study. And that was where Plymouth State University partnered with researchers at University of New Hampshire. Through that, we had our field campaign assessing wildlife activity using cameras. And then we just about wrapped that up, and we are now in our prioritizing mitigative action phase. So today's talk is going to walk you through at least the last 4 of these. So to start off with New Hampshire Fish and Game's efforts, this was a predictive wildlife corridor mapping initiative. And this started back before 2020. I think it's been most recently updated in 2020, but the wheels were in motion before that. And as part of this, the corridors have been identified. And on the map on the left, you're seeing at the very bottom of the legend, the wildlife connectivity. And really that's rated by the landscape being permeable to wildlife movement. So first, the model identified movement and dispersal using this wildlife connectivity model, as you see there. And then they use Linkage Mapper, which is a GIS program to connect and identify where specific corridors could be by individual species of interest, but then also compiled together. And on the right-hand side, you'll see that there are potential wildlife corridors and wildlife secondary corridors in that lighter yellow. And those are the connectors between what we refer to as our prioritized habitat blocks, which are areas of over 50 acres that have been already recognized of areas or ranked of highest importance in our state for biological activity. So that was happening on the fish and game side of things. And then at the same time, the Department of Transportation funded this study that was really sent to identify what data sources are available in our state to inform this potential problem with wildlife passage over our roadways. And what ended up happening is we were sort of funded to be able to tackle several objectives, but these included being able to compile, map, and analyze wildlife vehicle collision data, as well as animal carcass data, so roadkill data, and wildlife tracking data to better understand what was available throughout our state. So very quickly into the study, we realized that there's absolutely no reliable roadkill data. It's completely haphazard. It's taken sometimes as wildlife sighting data, sighting data, and other times not recorded. So we very quickly realized that we couldn't use animal carcass data to inform any decision-making, especially at the state level. We also looked at our wildlife sighting data and realized pretty much a similar thing. It is, haphazard. People would report when they see some things, but not others. And it wasn't comprehensive enough across the state to inform any decisions or even to really complement the data that we have. So we ended up working only with vehicle crash reports, and these are what I refer to as WVCs for the rest of the talk. We were initially given data between 2002 and 2019, and then at the end of that cycle, of our first cycle, we also got 2020 and 21 data that's been incorporated into the analysis. So there were over 33,000 wildlife vehicle collisions that were reported between this time period. And this graphic is here to show you the interannual patterns in that, and also for you to understand what percent of all crashes are actual wildlife vehicle collisions. So we had an annual average of about 1,449 collisions that had occurred and involved animals, and that constituted about 4.5% of all collisions in our state during that time period. Other very brief things I can tell you about the data is that we realized very quickly that our assumptions that high-speed roadways were going to be our problem area, so our interstates or our separated highways. We very quickly found out that wasn't the case. 36% of the collisions that are reported with animals occurred on local roads. So that really put into question the fact that a lot of this was happening in areas that we didn't think was happening, and that we needed to pay attention to all different roadways as part of this. And I threw in this note on the bottom. It's going to become important later, but species was not reported for almost all of the records in this 33,000 record data set, unfortunately. It was only in 2017 was species reported, and it was only partially reported. And I can tell you, I have called up every possible tree to try to figure out why that is the case here in New Hampshire, and no one seems to have the answer as to why that happened. So we ended up having to take a couple of extra steps to inform our actions. So the second phase of our analysis was thinking, kind of using the data that we have, again, just these collision data, and analyzing temporal trends to try to get a feel for when the problem is occurring. And it's pretty much what you would expect to see, especially in the Northeast. If we start off with our seasonal trends on the right, see that there are 2 seasons with a lot of collisions. These correlate directly to animal movement and throughout our state. So we see a fall peak and a spring peak, and that's when animals are really moving around for mating purposes, for foraging purposes, preparing and whatnot for winter as we go. So we do see those humps there, and we see those as well at the daily rate. So if we look at diurnal patterns here on the left, you're going to see differences associated with the seasons. But the clearest patterns you see are the morning and the nighttime or the evening. And those change based on when we have our daylight changing in our east area, right? So we have peaks later in our spring, earlier in the fall, again, coinciding with our diurnal rhythms. And we also try to separate this out by commuting. So everybody commuting to work on the weekday in blue versus weekend patterns. And you do see a little bit of an elevation with weekday patterns, but mostly given the fact that we're seeing similar humps in weekend patterns, it's suggesting largely animal movement rather than just our commuting pattern. Let's see. In order to really work with the data, which is a collision data point, right? So it's just a point on a map at that point. What we really wanted to do was aggregate the data up to the road segment level, and you've seen this in other presentations already. So in doing that, we came up with 3 metrics that were going to be helpful for us. And I should also mention that when working with our partners, largely Department of Transportation and Fish and Game, we recognize that there's so much interannual variability, and having a data set as long as we had, it was really challenging to work with each year alone. So instead, we decided that a 5-year window was going to be helpful. And because we initially started with data from 2019, our window was 2015 to 2019, 2010 to 2014, and then back beyond that, we lumped everything together. So what we're working with here is trying to aggregate point data up into a road segment. These road segments are not equal in length, which poses its own problem. So we ended up also computing the density, which is the number of collisions with wildlife that occurred per mile. And because we were working over a multi-year period and we got that last chunk of data for 2 years instead of 5 years, we also computed the annual average of WVCs as a way of standardizing the total WVCs over time. Once we had those road level aggregates, we were then able to look at spatial patterns at the state level, at the regional level, at the municipality level, even at a given roadway level. And even from these maps here, you can see a pretty substantial shift in where the hotspots were. So the areas that are in red are road segments that had a higher frequency of wildlife collisions during their period. And again, this is annual average, so we're comparing oranges to oranges here. And one of the things that's really notable is that in the most recent window in this image is 2015, we see areas where there were problems for almost 15 years prior, no longer being problems. And while we might initially jump at that and be like, yeah, that's great, this is such a good thing, we have less WVCs, there were no real mitigative actions that have occurred to shift that. And so the prevailing thought right now is that it's really the wildlife populations that have dwindled in those areas that have decreased the interaction with roads more so than there was any conservation or mitigative action. So that's also kind of sad at this point. So we're moving into the next phase now, and you can see that down on the bottom of the slide. We're in the prioritizing sites for field monitoring. And the reason why we need this field monitoring goes back to because we don't have any animal or wildlife data associated with our records. So when it comes to mitigating and thinking about, the size and dimensions of an underpass, for example, we can't really do that without knowing what species are around and are using it. So that was mainly this motivation for what we have a second funded project that is really a field campaign to assess what species are in the area. So when we were preparing for that and trying to identify which sites, we had several questions that we had to discuss with our technical advisory group, and that was largely which metric should carry favor. If we're thinking about it from a total number of collisions versus the density, is one better than the other? What's the window of time we should be thinking about? Should there be other things considered? So for example, should we be thinking about where Department of Transportation projects might be occurring over the next 5 to 10 years? Should we be thinking about feasibility at the site level to do any changes? Should we be thinking about the cost? Should we be thinking about species of concern, human risk, things like that? And ultimately what it came down to is that we prioritized based on projects, but ultimately where we saw the highest number of collisions with both different metrics as we go through. And the challenge with that is that both of those metrics have their own bias. So over on the left, you're going to see total WVCs that occurred during that 5-year period. And these aren't the average at this point. But these are biased towards longer road segments where you're more likely just by probability to have more points along those roads, more collisions. Whereas where if you look at density, what really gets highlighted is going to be these very, very short segments where several collisions occurred, but the segment length is less than a mile. So in this one, if you look at the legend, the highest value is over 1,000, right? There were not 1,000 collisions on that roadway, but instead it's just a tiny road segment, probably an on-ramp, that had maybe 2 or 3 collisions. But when you take that and you divide and you look at the density, the number is huge. So we had to kind of look at both as our prioritization strategy. So what we started with, what we wanted to identify was about 40 road segments that were considered high frequency roadways or hotspots, if you will. And that's the map you see all the way on the left. But from that, we knew that we could really only instrument about at most 15 sites, and we ended at 13 sites. So we had our initial criteria, which was looking at density, annual average, and then also the kernel density, which led to the hotspot maps that you see there, a little different from looking at it a roadway. So that's more of a neighborhood approach. And we were able to filter that down into a subset of 13 sites that we were able to instrument. And that's the map you see in the center of the screen. So these sites represent a combination of criteria that includes the time period between 2015 and 2019 for total or annual average WVCs from that time period, as well as criteria for 2020 and 2021. So those are kind of our top sites. So any site that kind of fell as a hotspot between 2 different criteria, 2 different time periods, that was selected and brought into the study. And then we also had about 6 sites where the annual average was high in 2015 to 2019. Again, another one from top density, and I don't need to read these for you. It's suffice to say that that's how we distilled them down. We also ended up with a fairly good representation throughout the state of northern site and southern sites. However, it is fairly dominated by the southeast, which worked out well for our crew that largely came out of UNH, that is in the southeast portion of our state, but it did also leave a bit of a gap in the middle. Okay, so the fun part is the field campaign, and this is the newest stuff. So if anybody was at Burlington 2 years ago, I presented a lot of what you've already seen in more detail. So this was our field campaign, and this lasted over 2 seasons, or actually, I should say 1.5 years. So we had 2 falls and a spring of data. And what you see on the left is what's considered like a typical design for this type of work, where you might be looking at a crossing structure and monitoring what species are going over that crossing structure. But our questions were a little bit bigger. Our questions were not just who's using an existing crossing, which in our case is just mostly going to be culverts or a bridge, so a stream road crossing, but then also who's in the area, who could be facilitated in a crossing of some sort, probably an underpass, and what species are going to be vulnerable in that area, and also what species are actively using the roadway. So our framework on the right is showing you how we use 6 cameras at every site to better understand the wildlife activity in the area. And I wanted to try to distill this down as easy as possible, showing you the 3 questions that we mentioned that we were really focused on, and highlight where the cameras were, give you the results in the middle, and then just give you like a fun picture to look at. So when we were thinking about who's nearby, right? What wildlife is in the area? What's our potential biodiversity at this site? We had those cameras set up to monitor that. What we found was that we had a great representation of species pretty common in the area, with the highest detections being of raccoons and then also of deer in that area.
2 minutes, Amy.
Great, thank you. I hope that includes the time that I got to make up too. Anyway, we'll see that later. So you see that raccoons had accounted for a huge portion of who's nearby, and you'll see that carry through with all the different levels here as well. If we look at who's using the structure, right, raccoons were also in large majority of what was being facilitated through those existing culverts. And then we see a few others that were attempting to use the structures, and those are represented there in that middle graph as we go. Let's see. But if we look at who successfully crossed through a culvert, meaning they started and finished their journey on the other end of it, really, we're just seeing raccoons using it. There are some other species that detections were noted for. So we had bobcat that crossed through. We definitely had some possums and some red foxes go through, but species that did not go through included deer, and let's see, bear, coyote, deer, and turkeys did not have any successful crossings, and raccoons accounted for 97% of that. So then if we think about who's crossing the road, we see again deer, which is not surprising to anybody from the Northeast or the Mid-Atlantic or the Southeast. We have tons of white-tailed deer that are crossing the roads. And then we also, of course, had a red fox in that area as well as a high crossing point, and turkeys. Moose were only detected at 2 sites, but they were very frequently detected. So those 2 sites have already become a priority for us because thinking about human safety and well-being, a moose collision is extremely damaging and it does not work out well for either parties involved in that. So I hope these videos come through on your end as well. I just wanted to show you the benefit of using wildlife cams for this study is because we were able to really see the behavior of species using, as you can see on the left, or attempting, but then backing away from it. And, we're not really sure, are you looking for prey or are you just checking it out to say, I could go under that or I'm not going to, but it's really helpful information for seeing those things live with our videos. So I know I'm running out of time, but I am getting really close. And I just wanted to show this one because I think this one's also really helpful to distill down. So what this figure is showing you is species that were using an underpass, in this case, a culvert. And those are the species you see in that middle column right there. But then we're also seeing them still on the roadside, which means that they are not totally being served by the underpass or the culvert that's there. And that makes sense because they weren't designed for them. These are culverts that are designed for passing water, not necessarily the species that are using them. So that's really helpful for us for understanding how to mitigate moving forward. So at this stage, what we're looking at is all of the parameters that you see on the screen for being able to take what we've gotten from our wildlife camera study, from our GIS analysis, pulling it all together, as well as information from the crossings that exist, these culverts that exist. I'm thinking about aquatic organism passage at the same time, and we're trying to figure out which criteria are going to be the most important for deciding where to mitigate and what rank or what weight should those be given. So we're working through that process right now with our technical advisory committee and our partners. And we recently had a meeting where we shared all this information with them. And this is an example of what we did for every site. This is the information that we're pulling together to try to synthesize, to be able to look at not just what we saw from the WVC analysis, but also what we saw from the camera study, and then integrating other statewide data sets, including the condition of our culverts and whether they need to be updated for aquatic organism passage or for hydrologic vulnerability as well. So with that, I'm going to say thank you for your attention. Thank you for your patience, for everybody who stayed in the Zoom room and stayed in our room, or in there in Denver. I think that's awesome. Thank you. And, for your attention, pay attention to the roads. And then last, I just wanted to leave this up there. So if you're interested in how we've been also doing a little bit of outreach and decision support, the 2 QR codes up at the top show you a story map that was designed largely for InReach for New Hampshire Department of Transportation, but then also the statewide mapper we have that shows where the collisions are occurring and some of the metrics that we worked with as well. So again, thank you for your patience. I appreciate it.
One question. Otherwise, here's all of Amy's information. Contact her there.
Yeah.
Yeah. No, you're fine. Go ahead.
Hi, Amy. Thanks for your presentation. We just did something similar in Brazil. We just launched a plan that obligates road companies to do like this analysis, but we have to divide the animals into functional groups in order for the analysis to be right. Otherwise, it would be biased. So we divided into primate monkeys to do the analysis. Otherwise, there would be like the hotspots would be all messed up. And then the big mammals, they use this only wet passages, the ones that go inside the water, and the small animals, and also the avian animals, bats and stuff. And but by the time they didn't divide into functional groups, our analysis were like completely messed up. We couldn't find the hotspots because they were all together. By the time we divided, we could do it better in the state.
Can you repeat all that?
I'm just asking for if they thought about it dividing.
Yeah.
Functional group, if it's for you, it's a thing or not.
Yeah, so in Brazil, they launched a similar requirement of the Department of Roads and required an analysis similar to this, but they essentially categorized their animals by like primates, large mammals, some based on habitat selection, like they go through the water, they like wetlands versus not, avian, so they categorize things all differently because otherwise they were unable to detect hotspots if it was all jumbled together, but they were better able to detect hotspots of roadkill by categorizing the animal types. Is that fair?
Yeah.
Okay. So
Thank you for that. Thank you for that.
have you considered anything like that, or what do you think about that?
Well, our challenge is that we don't have that level of species data except for the sites where we've put cameras, but we absolutely have thought about the most meaningful way to do it. And up north in New Hampshire, where moose are prevalent, but maybe not detected, we're using more of like the umbrella approach, which is you build it for a moose and then at least everything else can pass. Recognizing that there are going to be some species that may not like it that big. So we're using that approach, but I think one of our challenges, again, is having that species-specific data. I will say that one of the benefits of having this project is that we have created pressure for two things. One is a change to make sure that every collision from here on out has a species recorded with it. So that has been reintroduced to the protocol. So data moving forward will be collected. And then also we have a roadkill animal carcass campaign that is in process. It's starting and it's hopefully getting traction so that we will also have that data moving forward. So that's the beauty of at least the first couple of years of this, is that we've been able to lean in and say, we need this data because it is not cost effective to put cameras out everywhere. So that's helpful. But for the sites we do have, yes. And I love the idea that you're using like a functional approach for that because it makes the most sense. So we will definitely look at trying to do that as best we can. Thank you for that comment and sharing.
Yeah, great question. Great job. Okay, thank you so much, Amy. Great job, everybody. Let's hear for all of our speakers' discussion.